From now until a couple of weeks later, don't have to ask me, right? I'm sure some of you will be so tempted to ask. So, uh, do do we have to study last term's topics, all the topics? And of course, right? Once again, no, right? Right. So only this term, we only have 5 topics that we have covered this term, and your semester exam is based on all the 5 topics. Okay. Then common question: will there be sketches? And yes, of course, right. There will be some I don't know, 2 or 3 questions that may require to do some simple sketches. And what are the simple sketches? I've already done that with you guys in class during those video lessons here, and also I have explained quite clearly what kind of sketches are not required, right? Yeah, some of the sketches that I've done like in 1 to 2 minutes, probably those kind of sketches, right? Sketches will be something that you should be able to do within 5 minutes, right? Including any labeling, right? Of course, don't expect that you are required to sketch like a stern tube system, right? Not that kind of sketch. That's going to take you probably more than half an hour. Of course, some of you might have already practiced that. Okay, and but you guys know what I'm talking about, right? Those sketches that are done in like 1-2 minutes, those kind of sketch. And for any of the sketch that you need to accompany your answer, freehand it's acceptable, right? Freehand, but try to be as neat as possible, because marks will be given for neatness, not just for your sketches, for your overall handwriting, for your overall, the way you present your answers, right? The overall thing, your handwriting, if it's really so small that I need to use a magnifying glass, if I have problem reading, then it's kind of like considered not very tidy. Okay, so be as tidy as possible. Grammar, your usual grammar. This is not English test, or your usual grammar. A little bit, all doesn't matter. Spelling is not the biggest requirement here, right? But you know how to spell as closely as possible. Okay, and where you need to put a comma, where you need to put a full stop, please do so. Okay. Try to be as neat as possible, and once again, use only black or blue pens, right? Black or blue ink. Okay, and of course, sketches you can use your usual pencils. All right. No other color ink to be used. Otherwise, those colored wrong color answers will not be marked. All right. Okay, and if you're not really that great about drawing straight lines freehand, you grab anything, right? Bring along a ruler, a compass. You can't draw circles that well. Use a compass or whatever templates you may want to use. All right. Otherwise, probably you would have already practiced, right, doing freehand. Okay, so I'm going to go in now to all the topics, right? So let me just have a quick look how many people we have. 22. I'm only 22 names. Just 3 more added from earlier on, 5 minutes ago, 19. Okay, so please, guys, those of you logged in, continue to remind all your other friends. All right. Okay. First thing I want to talk about is this, right? We talked about this so many times, right? Coupling both with a cylindrical body and a slightly tapered forward end for easy entry is called a one, right? So this is all about the shafting system, right, from the beginning of this term. Okay. So again, go for all the keywords, right? Cylindrical body is a keyword. Cylindrical body. The slightly tapered forward end, that one is just for you to imagine a little bit where could that be. Okay. And of course, the answer is it a small taper boat? Is it a tapered boat? Or is it a parallel shank boat? Or is it a medium taper boat, if there is such a thing? Okay, of course, the answer is your parallel shank boats, right? Parallel shank boat, shank, the shank is parallel, okay? Shank refers to the main body, right? The cylindrical part. The slight taper is only at the forward end. The forward end is here, okay? All right, okay? Remember, parallel, cylindrical body, parallel sides, okay? Right, I'm not going to spend too much time talking about that. Okay, what contributes to stresses in the propeller shafting system? Okay, by now you should already understood that when we talk about propeller shafting system, whatever stresses affecting it is the same kind of stresses affecting the whole shafting system, right? Because the whole shafting system got to be as straight as possible. Okay, so stresses occur when things are there to disturb this straightness of the whole shafting system. So what contributes, right? What are the things? Basically, if you think of one set of shafting system, the same similar thing will apply to the whole shafting system. Okay, so this will be the slide there that we are talking about. Tail shaft, propeller shaft rests on stern tube bearings, carry the propeller after end. Okay, this is what the propeller shaft is subject to, right? Torsional stresses due to rotation, right? Bending stress due to the weight of the propeller. Okay, so being a propeller shaft, you have an additional stress there, right? The weight of the propeller at the end of the tail shaft that's causing this cantilever effect. You guys know what's cantilever effect, right? That's in your mechanics, right? And you also have your usual compressive and tensile stresses. Compressive, tensile, okay? So compressive stresses are there when the ship is moving in the ahead direction, right? The propeller is pushing the ship in the ahead direction. So the thrust force from the propeller is pushing along the whole shafting system. And finally, of course, you're going to end up where? We'll come to that, right? You know, all you guys know where the propeller shaft forces going to end up, right? Definitely it's not going to end up in the crankshaft of the engine, right? Okay, so but compressive and tensile stresses affects the whole shafting system. And of course, tensile stress you have there when the ship is going astern. The propeller is trying to pull the whole shafting system away, right? That's where the ship moves astern, right? So bending stresses, compressive tensile stresses affect the whole system. Torsional stresses affect the whole system. Bending stresses not only due to propeller, due to the fluctuating motion, right, of the ship's hull as well. Okay, so you can add that on as well, right, due to the hogging, sagging of the ship, for example. But of course, for propeller shaft, you have these additional bending stress caused by the weight of the propeller, right? Okay, so and in the case of intermediate shaft, you have compressive stress, tensile stress, torsional stress, bending the same, right? So the same thing applies to all these stresses apply to propeller shaft as well. Okay, right? Okay, so let's move on. You can put on the rest also. So many to choose from. Okay, next, an intermediate shaft bearing typically provides bearing surface to what extent of the intermediate shaft? Of course, you know that the intermediate shaft bearing is supporting the main job, right? Supporting the intermediate shaft, so it's supporting the weight of the intermediate shaft, and the next job is to keep it perfectly aligned, right, with the rest of the shafting system. Okay, so the bearing surface support which part of the intermediate shaft? Is it the full circle, half circle, 1/4, 1/3 of the top or bottom, right? Basically, is it the lower half of the intermediate shaft circumference or the upper half, right? Or lower 1/3 or the complete shaft circle, okay? Intermediate shaft bearing. Don't get confused with the plumber block bearing, okay? Here is specifically intermediate shaft bearing. And of course, the answer is there in the slide, right? It support the lower half only, right? The bearing surface of white metal provided only the lower half of the intermediate shaft bearing. Okay, that's all you need, right? For intermediate shaft of here. For this topic, we are always talking about the large ocean going ships. Okay. Right, any questions, guys, so far? Let me take a quick peek. How many do we have? We still have 22, so still got so many missing guys. All right. Okay, once again, please, inform the rest of those guys. Okay, let me. I'm not so sure you guys can see all the names there. Let me read out the names. Some did not write. Okay, the first name I have is dash dash. So there's a name called dash dash. They have I see Adele, I see Alan, I see Akil, I see Asha, I see Darius, I see Daryl, I see Jaden So, of course, a couple of Jaden around. Jin Chen, I see Lavender, I see Nonla, I see Wan Hao, I see Hidayat, I see Yu Tong, I see Ona, Putri is there, Reina, Ria, Sarah, Soumya, Kaiser, I see Zikri, right? So that's all the names I see. So if you see some of your friends not here, please let them know also. Okay. Okay, next. The type of seal commonly used in oil lubricated stern tubes. Right, we just done that quite recently. Right? What is the type of seal commonly used in oil lubricated stern tubes? Is it stuffing box? You guys learn about stuffing box from somewhere, right? Is it a mechanical seal? Is it a labyrinth seal? Right? Of course, it is called a lip seal, right? We have all this in your slides. Okay, lip seal, lip. Okay. Okay, so very uniquely, the seal, the type of seal used for stern tube that wraps around the propeller shaft, right? Of course, you have a set of those. It's not just one, right? And you have your aft seal, you have your forward seal, right? So both are using lip seal, and this is a special design where you're using the hydrostatic pressure of the water outside to press the seal even tighter, right, around the shaft, and the hydrostatic pressure of the oil inside also helps to press the lip seal very tight around the propeller shaft, right, due to the unique shape. Sometimes people refer to this unique shape as the dog leg. You know, dog leg. Most of you have dogs, so you know dog legs, right? That's the shape of the dog leg. Okay, this is a term used in golf also. So if any one of you is familiar with golf, right? Or maybe your parents play golf, sometimes you hear them say, "Oh, this part of the course here is a dog leg." Okay, like a curve. Okay, anyway, a lip seal. Lip seal is not stuffing box, not mechanical seal, not labyrinth seal. Okay, stuffing box is used for two-stroke engines, no piston rod. Okay, so that's in MEK. Mechanical seals are used usually in pumps. Labyrinth seal used in the steam turbine system. Okay, so it's lip seal. How is a propeller secured and prevented from rotating on the tail shaft? Again, we talked about that very, very recently, right? Propeller secured to the tail shaft by what means, right? Okay. So again, your propeller notes have all these things here. Friction grip, fuel grip nut, key, right? So which one is it, right? So the answer is that, right? Held in place by friction grip. So first of all, you have to depend on the friction grip, which is the taper against the taper, right? The taper of the tail, the end of the tail shaft is exactly the same taper as the hole in the propeller hub, right? The propeller hub. So it fits nicely, right? So of course, you're not going to get 100% contact surface. As long as you get about 75, 80% or more then of contact surface, right? Matching each other, then that should be more than sufficient grip for the propeller to stay on the tail shaft forever, right? Forever. Okay. That's the beauty of having tapers, right? Taper. Okay, and the key may be included. We talk about that also. We spend quite some time, even done a sketch on the board, right, during tutorials. A keyway arrangement may be added for added security to prevent the propeller from turning around the shaft. But this keyway arrangement is only required for smaller propellers, right? So a lot of smaller propellers may not even have these, but some for added, right, added security in case whatever propeller have slightly loosened itself from the tail shaft, then the keyway will have to make keep it from turning around the propeller shaft. Right? So it's just to add on to the additional holding strength, right, to keep the propeller on the shaft. Okay, so large propellers, large tail shaft you don't need because the amount of surface area is more than sufficient to give you more than sufficient friction grip, right? Okay. So this is the answer, not by pilgrim nut. The pilgrim nut is for you to get a friction grip, but after that, the pilgrim nut has no purpose already, right? Until the next time the propeller is required to be removed, right? Okay. So the pilgrim nut is to install it or secure it, and after that, once you got the enough friction grip, the pilgrim nut's job is done. Okay, so it's friction grip and or key. Okay. Right? And or. So you guys also know what's the meaning of and/or, right? I explained that in class also. Okay, function of the truss block. So what is it, right? Function of the truss block: to accept thrust produced from propeller and distribute evenly to the ship structure, right? Just a few words there. Of course, you can paraphrase it right, any way you want, but must carry the same meaning, right? So function of the thrust block: accept the thrust from the propeller, distribute evenly to the ship structure. Instead of letting the thrust force end up in the engine, right, and end up against the crankshaft, and the crankshaft will get damaged, engine will get damaged. So thrust block, propeller, thrust force coming back along the shafting system ends at the thrust block. Is directed downwards to the ship structure. Okay, so the ship moves, right, either ahead or astern. Okay. Okay, pretty straightforward there. So what type of bearings? What type of bearings uses hydrodynamic lubrication as the key method of lubrication, right? Hydrodynamic. So if you know the bearing, of course, you know it uses hydrodynamic. So that's the reverse. Hydrodynamic lubrication is part of what kind of lubrication style, right? So of course, there's a little video there I've included in your bright space, and which picture shows bush bearing. So we know that we are talking about bush bearing. Of course, it's C, right? C is the one that we are talking about, bush bearing. So this is the kind of bearing that uses hydrodynamic lubrication, right? You don't need to have added pressure, or you don't need a pump to create the pressure, right, to lubricate the bearing. The bearing lubricates itself as long as you have continuous supply of lube oil, right, into the bearing and onto the shaft or whatever. Yeah? Whatever that's sticking on the shaft, it will get squeezed into the bearing. Excuse me. Right. So bush bearings, most of the bearings that we talk about, right, for the whole shafting system, including the propeller shaft, right? So the stern tube is a bush bearing, intermediate shaft bearing is a bush bearing. There is also a set of bush bearings inside the thrust bearing, right? Thrust bearing, of course, you know, there's a bush bearing and there are all the other type of bearings, right? A special type we're going to talk about in another slide here, okay? So bush bearing, hydrodynamic lubrication, right? These two go hand in hand. Okay, bush bearing. Okay, what type of force should not act on the crankshaft? Should not, right? So yeah, you're going the reverse, right? The crankshaft should not accept certain type of force, right? Crankshaft, where are the forces coming from? From the piston, from the connecting rod, right? That's what the crankshaft is receiving the force from, not from anywhere else. Of course, the thrust developed by the propeller should never end up, you know, at the crankshaft. Okay, that's what the thrust block's job is for. Okay, otherwise the crankshaft will be critically damaged. So the thrust from the propeller, okay, so that has to go through the thrust block, not end up at the crankshaft. Okay, and look at that familiar sketch there, right? Okay, for sure we're going to talk about that again, right, soon. Okay, so what type of force? The thrust developed by the propeller, thrust force from the propeller. Okay, next, what is the key advantage of a ship's bow thruster? Bow thruster. Okay, I spent quite a bit of time talking about this, about thrusters. So thrusters usually refers to either the bow thruster or the stern thrusters, right? So these required when the ship is not moving and when the ship is required, when the ship is not moving forward or up, when the ship is required to move sideways, right? Then you need this kind of thrusters, either the bow thruster or the stern thruster or both, right? Some ships are fitted with both. Okay, so this is to cut down on requirement for tugboats, right? Or not even cut down if you have both bow and stern thruster, the ship does not even need any tugboat at all, okay? Right? Because you got all the power, right, to move the ship sideways, right, by the ship itself, right? Okay. So pretty straightforward there. Okay, international requirements, mandates. Mandates means it's a requirement, right? Mandatory requirement. That the ship steering gear shall be capable of doing what to the rudder, right? So of course there are a whole list of requirements, but you got to guess which is the correct one from whatever is given here, right? So is it this? Supposed to turn the rudder? Of course, it's supposed to turn the rudder. Steering gear must turn the rudder. What about this? Right, 35 degrees on either side to 30 degrees on either side in not more than 20 seconds, right? So it is all of this, right? Should be the steering gear should be able to turn the rudder from 35 degrees on one side to 35 degrees on the other side at maximum speed ahead and at the deepest drop. Deepest drop means fully loaded. That means the propeller and rudder, they are all completely submerged, right? And very importantly, 35 degrees on either side either the port side or starboard side, to 30 degrees on the other side in not more than 28 seconds, right? Remember the 30, 30, the 35, 30 to 28, right? 35, 30, 28, the OTP. Remember we talk about OTP? You guys have to deal with a lot of OTPs, but this is like a permanent OTP, 35, 30, 28. Okay. Okay, here, so just now you got to start to read carefully, right? Because there's one part and two part, right? Part one, part two. Okay, part one here is talking about why is alignment of shafting arrangement very important. Why is it so important? We need to have perfect alignment, right? And part two of this slide here is talking about 3 shaft alignment methods. There are more than 3, but good to know at least 3. Okay, slide V2, number 6 slide. Okay, shaft alignment. Why is it important? Due to this, because the shafting system rests on regular, the ship structure that the shafting rests on regularly experience a combination of hogging and sagging effects, different loading conditions, different draft conditions, different wave conditions, and all these create a lot of all kinds of stresses on the shafting system. Okay, and because of all these things happening when the ship is in motion, right? Even when the ship is just floating around, proper alignment of the shafting has to be kept in check. So you want the whole shafting system to be as perfectly aligned as possible, right? So the center line of all the shafting system must be as straight a line as possible. That's what the alignment is all about, right? Both top and bottom and sideways, right? So all around, as long as the center line of the passes through the whole shafting system, from the tail shaft through the intermediate shaft to the thrust shaft and through the crankshaft, it must be as perfect a line as possible. Okay? Just due to all these stresses. Okay, all the forces. And 3 shaft alignment methods. You have here 5 to choose from, right? So piano wire, micrometer, feelers between coupling faces, optical method, or laser method. 23. Okay. Right, next, propellers. What's the difference between fixed pitch propeller and controllable pitch propeller, or CPP? Right? Some major differences are there. And part 2 here, 5 advantages of CPP. Right? A lot of advantages of CPP in certain applications, of course. Right? Okay, difference between fixed pitch propeller here is in your notes. The blade angle of a fixed pitch propeller is fixed and cannot be changed, while a blade angle of a controllable pitch propeller can be changed and controlled by means of hydraulic mechanism, right, which is generally positioned within the shaft and the hub of the propeller, right? The hub of the propeller. Okay, so if you can paraphrase this, fine, right? So, which is a good thing also. If you can paraphrase it, it also shows a full understanding of what's the difference between these two. Okay. Right, next, 5 advantages of CPP. So many, right? So you only need to know 5 advantages of CPP. Can control 0 to 100% at any desired thrust from propeller. 0 to 100%. Where fixed pitch propeller, you have some limitations, right? Because you can't go very, very slow RPMs, right? Remember the stress in class that in a 2-stroke engine, which usually directly coupled to the shafting system and the propeller. So if the main engine is turning at 30 RPM, 30, the propeller is turning at 30 or 30 RPM, right? Anything less than that, the engine will stop, right? Two-stroke engine cannot run at very, very low speed. So the slowest speed for the propeller will be limited to 30 RPM, 30. Okay, of course, you can go all the way up to 80 RPM, right, for some engines. Here we are talking about two-stroke engines, okay? Whereas CPP, you can